Hello, everyone. Welcome to Chemistry with Professor John Nguyen. For today, I would like to show you how to name alkanes. Okay, and if we have time, we'll look at the stereochemistry. All right. Now, alkanes are organic compounds that contain only carbon-carbon and carbon-hydrogen single bonds. Okay. They are also known to be saturated because they only have single bonds. Unsaturated would be with double bond or triple bonds. Okay. Now the general formula is Cn. Um, that's N is the number of carbon, and then you double that 2N plus 2. That will give you number of hydrogens. Okay. For example, if you have one carbon, if you take 1 times 2 plus 2, that's equal to 4. So you get yourself a formula CH4. Okay. If you have C2, 2 carbon, 2 times 2, that's 4 plus 2, that's 6. So you have 6 hydrogens. Okay. That's how it works. Okay. Now, the rule is pretty simple. We need to find the longest continuous carbon chains, and you number them. Okay. Now, any carbon that's not numbered, we call that a branch, and we have a few different branches that we need to focus on here. CH3 is called metal. Again, if it's not numbered, CH3 is a branch called metal. CH3CH2 is called ethyl. CH3CH2CH2, notice it's straight, we call that propyl. But if it's connect in the middle, which surrounded by 2CH2, we call that a isopropyl. And you got 3CH2, 3 methyl, we call that a third butyl or T-butyl. We also have other branches like halogens. Fluorine, we call that fluoro. Chlorine, we call that chloro. Bromine, we call bromo. And iodide, we call iodo. Okay? Now, when we have more than one branch, um, different kind, we have to list them in alphabetical order. If the same kind, then we use the di for 2, tri for 3, tetra for 4, so on and so forth. All right. Now, let me show you, before we get into naming, let me show you the basic structure first, okay? Here you have 3 carbon. That's the molecular formula. You multiply it by 2, which is 6 plus 2, you get 8 hydrogens. That's the formula for alkane, okay? Now, if you draw them out, show the structure, that will be CH3, CH2, and CH3. Notice the middle one is CH2 because carbon already have 2 bonds. Plus 2 bonds from the hydrogen make it 4. As long as you have carbon with 4 bonds, you are set, okay? Now, if you don't want to write a formula like that, you can do a very quick way. Each carbon is a dot, okay? So you got 3 carbon, 3 dots, and you angle them a little bit so that way you can recognize them easily, okay? So, and again, each carbon has 4 bonds, all right? So that's the basic, how you draw a structure. Now here's another example. You got the condensed formulas, and then you get skeleton formula, which only show the functional group and the carbon and any special bond, functional group again. Now, if you want to do the line, you base on the carbon. 1, 2, 3, 4, 5 carbon. So that's 1, 2, 3, 4, 5 carbon. And you always want to angle them so you can recognize the carbon easy, much easier, okay? Now, a little bit of review about functional group and class name that we're talking about. Remember, functional group is the structure. This is the functional group. It has a special name, class name. We call that an aldehyde. C-double-bond-O with the hydrogens. Notice you don't see the hydrogens. You only see carbon on both sides. That's a ketone. If you see a hexagon with 3 alternating double bond, double single, double single, double single, that's called aromatic. Okay? If you have aromatic with the OH, OH alone is an alcohol. You got aromatic with OH, that's called phenol. Okay? Amine is any compound with nitrogens, and it could be NH2, it could be NH, it could be N. Okay? C-double-bond-O and single-bond-O, we call that ester. If you have a hydrogen on the end, that will be carboxylic acid. Double bond, very straightforward, that's alkene. Triple bond, alkyne. Okay, so a little bit of warmed up on review on the functional group there. Okay, notice we have 10 fundamental alkanes. Okay, alkanes starting from methane, CH4, CH2, CH3, CH3. That's 2 carbon. That's ethane. And when you get to 3 or more carbons, we want to do it fast. And this is how you do it. 1, 2, 3. That's propane. 1, 2, 3, 4. That's butane. 1, 2, 3, 4, 5 pentane. You got 6 carbon hexane, 7 carbon heptane, 8 carbons octane, 9 carbon nonane, and 10 carbon decanes. Now the nice thing about this formula is you don't have to worry about hydrogens. Okay, they are there. They are hidden. Okay, they are secretly there. All right. Okay. Now talking about branches, I've got you covered. Okay. I call them nomenclature tree. You got all kinds of branches. Imagine like a tree. Okay, that's the longest continuous carbon chains. And you got fluoro, chloro, bromo, methyl. Ethyl is 2 carbon branch. Methyl is just a stick or 1 arm branch. That's a carbon. You got 2 ethyl. You got 3. Notice you got 3 connect right in the middle. That's isopropyl. Okay. If you have 3 connect continuously, that will be propyl. T-butyl. Look at T-butyl. It's pretty cool. It's got 3 arms. Okay. All right. Here's an example how you number them. So you got these molecules. You got 1, 2, 3, 4, 5, 6. The reason why you start 1 here on the left side because when you hit number 2, you got a branch. That is actually a branch because that's not numbered. Okay. 3, 4, you got another branch. And that's why you call it 2,4 dimethyl, meaning you have 2 methyl hexane. Now, here you start from this side as well, 1, 2, because your branch come right at number 2. If you go the other way, your branch will be 1, 2, 3. That's a little bit farther away. And you go 3, 4, you got a little Y shape. That must be isopropyl. You got a BR, you got a methyl, which is a 1 little arm. That's methyl, or you can think about 1 carbon. Okay, and then of course you can name that. That's an alkyne. All right, and here's the rule for naming again. Okay, so let's find the longest continuous carbon chains. Okay, so let's say this one, and make sure you pick the side that's closer to the branch, the first branch. So you want to go 1, 2. You don't want to go the other way because it's a little bit farther away. So that's what we call 2-chlorobutane. 4 carbon, it's a butane. Okay. Go back to this one, you see it. 4, 1, 2, 3, 4, butane. This one we have 1, 2, 3. Not the other way because it's a little bit farther. So you got 6, that's a hexane. And you got 3 fluoro. So you always put the number so we know where the fluoro is bonded to. It's bonded to carbon number 3. Okay. Now we got more for you. If you have two different branches, you alphabetize them. Okay. Now 1, 2. So you got 2 chloro. Chloro start with the C. It goes before the F. Fluoro. 3 fluoro. Butane. You got 1, 2, 3, 4, 5, 6. You got methyl versus bromo. So bromos go first. B, 3 bromo, 4 methyl hexane. B goes before M. Now, if you have a third butyl, third is a prefix, so it doesn't count. You're still based on the B. So we go 1, 2, 3, 4, 5. 4, you got a third butyl. 5, you got a chloro. So B goes before C. That's the point. Pretty good? Okay. Now, we also have cyclo. Okay. If we have a pentagon, we call that a cyclopentane because it's a 5 carbon, but it's enclosed structure. If you have one methyl, you don't have to number it. So just methyl cyclopentane. You got one branch, chloro, methyl cyclohexane. Cyclo, again, enclosed structure. One branch, no need numbers. However, if you have two branches, these are 2-arm branch or 2 carbon. They're both the same, and they are, each of them is an ethyl, so you call that a 1-1 because automatically that's number 1. And repeat number 1 because you have 2 branches, so that's why 1,1 diethylcycloheptane, because the ring has 7 carbon. This one has 8 carbon in a cyclic structure. So you put number 1 on the fluoro because F goes before I. 1, 2, 3, 4. So that's why you have 4. You don't want to go the other way because it's further. Okay. So 1 fluoro, 4 iodo, cyclooctane. Okay. Now that's again if you have a mono substitute, meaning one branch, you don't need to number it. Only if you have 2 or more. Okay. Thank you guys, and send me an email if you have any questions. Okay, I appreciate it. I'll see you next time. Okay, thank you.